Hello everyone, this is Hunter from Outtenastrophotography. Now I have been getting a lot of comments about how to combine your dual narrowband data between having the two filters that I recently did a review on, the Askar C1 and the C2 combo, which are both a HA and O3 for the C1 and the S2 O3 for the C2 filter. And when you combine them together, you'll be able to get a Hubble palette of SHO similar to the monochrome guys out there. So we're going to be teaching you through the process right now of how to combine and process your SHO images with these one-shot color cameras and with these two filters. Now, the data I'm going to be working with is what I shot just a few nights ago here in my backyard. We're going to be doing with the Monkey Head Nebula, as we are going to be looking at how to combine these two datas together to have one singular image that is SHO. Now on the left here is with the C1 filter, as we do have our hydrogen and our oxygen, and you can see we have a lot of strong colors of the red. That is that hydrogen, and right near the center, kind of like that offset white, that is your oxygen with this filter here. But what's the game changer is when you start imaging the same target with the S2 and O3, you start to notice that there is not much way in the sulfur data, which is overshadowing the oxygen data. You can see we have lots of rich blues and greens near the center here, which the hydrogen is a lot stronger of a wavelength bandpass than it is for oxygen. So when you're just imaging with the C1 filter, all you get is mostly hydrogen and a little bit of some oxygen, but a lot of the oxygen gets washed out, unfortunately. So this is why with this other bandpass of S2 and O3, we get to see that oxygen really shine in the process here. So these are just straight out of the stack. They are still linear. I haven't added any stretches to them whatsoever. But one thing to keep in mind that you do for this process here, you're going to be needing to add two utilities to your Pixin site. So the two things we're going to be needing for this processing video is something called narrowband normalization and the easy processing suite. I will be putting those repository links down in the description below. All you're going to do is just add them to make sure to have these to make this process much easier for you. So the first thing we are going to be doing is dynamic background extraction, which is going to be taking out any sort of gradients in the background. I went ahead and did the liberty of doing it for both of them. So you can see we have a little bit of a better, universal flat background of color. Same goes to the other filter on the right, the C2. And also change the identifiers as well for HAO3 on the left hand side, and then S2O3 on the right. Now the next thing we're going to be doing is the very important one is we need to make sure that these two images line up. Even though they were taken on the same night, there is still a little bit of a difference that you could be just offset just a little bit. So the first process we're going to be using is star alignment. You can find it under processes, all processes, and then find the star alignment tool. Now you're going to be looking for your reference image, since the one we're going to be using is the HAO3. So in the reference, you type in HAO3 and you take this little triangle and you put it over top of your S2O3, and this will align those two images together. It'll create a new one, so we can then get rid of the old one that we were working with. So now they will be perfectly aligned with each other. So we're going to delete that off. We're going to do an unlink stretch, and now when you go over top of the image here, it should be completely aligned. Like so. So now that we have our images aligned up, now where the fun begins. The first thing we're going to be doing is splitting the channels between R, G, and B on both of them. So for the HA03, we're going to go up over here to the split RGB channels. Now this is where we're going to be extracting our hydrogen alpha, our oxygen data from the RGB palettes. Now, hydrogen alpha is in the red spectrum. So when we do an unlinked stretch for this, you can see very, very rich detail of all that hydrogen alpha being picked up here in the Monkey Head Nebula. We're going to rename this one HA, and then we're going to be taking this to the side here because we're going to be using this for later. Now we are left with the green channel and the blue channel. So now we need to get our first data of the O3. So what we need to do is go to processes, go down to pixel math, and we're going to take these two images, the hydrogen alpha, oxygen 3 green, and the blue. We're just going to do some simple equations here. We're going to do this plus the G channel, and then you're going to combine them together straight up. And now we should be having our first oxygen data from the HA03 filter. So we're going to change the identifier to this to O31. Now we can get rid of these other blue and green channels because we are not going to be needing those now. So stick that off to the side as well. Now we're also going to be extracting the RGB channels from our S203 filter. Now in the red channel, when we stretch it out, you see it is not as strong. This is actually your sulfur data, because sulfur is in the red spectrum as well. So we're going to be renaming this one S2, and we're going to be sticking that aside, and then we're left with the green and blue channels on this one. Now we're going to go back to our pixel math. We're going to clear this out. Expression editor. Find our B channel plus our green. And then we're going to create a new image. And now we have our oxygen data from our second filter. So we're going to rename this O32. Now we can get rid of these other two channels. Alright, so we now have our hydrogen alpha, we have our sulfur 2, but then we have two oxygens. So how do we combine these together? Well, it's actually much easier than you think it is. Do the same thing like we did with the blue and green channels. Oxygen 1 plus oxygen 2. Create a new image. And just like that, we now have our combined oxygen data. Go ahead and rename this. So there we go. We now have our hydrogen alpha, our sulfur 2, and our oxygen data. Now that we have our three channels done, if you have the astronomical tool known as Blur Exterminator for doing deconvolution, now will be the time to use it on all three channels. So we're going to be going ahead and doing that in our processes, all processes, and then we're going to be finding Blur Exterminator. And we're just going to be using the default settings here with the automatic PSF, and we're going to be doing this to all three channels. Now that we have used Blur Exterminator on all three of our images, it's time to stretch out our images, but we have to make sure that they're at least at the same brightness for all three channels. If not, this process is going to look quite weird. That's why we're going to be using this easy processing tool, because there is a tool inside of this processing suite that already stretches the images pretty much at the same histogram level. So we're going to be going ahead and deselecting all of our images here. We're going to first start off with the hydrogen alpha. You can find this tool in the scripts, easy processing suite, and go to easy soft stretch. use the default settings, run easy soft stretch. Now you do this for all 3 images. Alright, now we have our stretched images of hydrogen alpha, oxygen 3, and sulfur 2. Now we're going to be combining these together to get our SHO color palette. We're going to be using LRGB combination, which can be found under processes, all processes. And then we're going to be finding the LRGB combination. So what I like to do for the luminance, since we didn't actually shoot for luminance, we're going to be using the hydrogen alpha channel for that. For red, since we're going to be doing the Hubble palette, that is our sulfur. For our green, that is our hydrogen alpha. And for our blue, our oxygen data. And then you're going to be clicking the little circle to apply globally. And there we go. We have combined our channels together to our start for our SHO color palette. Now, it will come out looking green because hydrogen is the strongest bandpass for any nebula. So we're going to be seeing a lot of green right off the bat. You can see some blue there in the center, but we're going to be having to work with the colors here, and that's where this next process is going to be used. So next we're going to be working with something known as narrowband normalization, but we need to remove the stars first. So if you have Star Exterminator, you can go ahead and use that, or if you don't, you can use StarNet 2. But I'm going to be using Star Exterminator, and we're going to be removing our stars. Alright, now that we have removed our stars, put them aside. Now we're going to be using narrowband normalization. Now this is a brand new tool that has been available to the public completely for free. You'll be able to really start seeing the color differences here in just a moment. We're going to be going to processes, all processes, and then we're going to find narrowband normalization. Which you're left with this window here. We can select our color palette. There is different versions that you can use, but we are going to be using SHO. Make sure to hit the preview button. And even already we're starting to see a little bit of that green beginning to fade off. And you can select different lightnesses to your liking. You can preserve the lightness or select the hydrogen to really bring out those regions right around the edge there. Don't really recommend the 031, it just makes it look weird. The S2 also makes it look weird. So either preserve it or turn it off completely. Or in any case, I'm going to be using the hydrogen alpha one because I really start to see the nice contrast here. And this is where your channel controls go. This one right here, the SCNR. You bring that slider over, it starts getting rid of all that weird green that we first had, and it starts replacing it with more of a gold color. And then we have these other controls here for oxygen 3 boost and sulfur 2 boost, which also enhances the color. So if we start bringing up the S2, we start to get a little bit more of that oranges color right around the edges there, and we can also boost up our oxygen a little bit more as well. This is the first step to start and have our colors that we're going to be working with. Also have highlight reduction and brightness you can mess around with. I'm going to bring up the highlight reduction up. Leave the brightness where it is, and I think that looks good so far. Alright, so we have our combined images. We got rid of that green. Even though we do have a lot of magenta in the background, we'll be able to take care of that here very quickly. We're going to be starting to make our color mask. So we're going to be finding the ring selection tool. I want to get rid of that magenta first in the background. So I'm going to be making a mask here, blur it, and then invert it. So it's only in the background. Go ahead and hide the mask. And a tool I like to use is under Utilities and is Correct Magenta Stars. And that basically just gets rid of all the magenta color around the outside. And there we go. All that magenta is now gone. So we're going to delete that mask. And now we get to start messing with some colors here. Now, beyond this point, this is where it just gets creative of however you like it. Whatever the colors that you like. There is many different ways to colorize and make, your color mask. You can use the range selection tool to make your color mask through. But I'm not going to bore you with going through the colors, but I'm going to speed up the process and show you what we end up with in the end. Now that I got my colors where I like them, now we are going to be working on removing a lot of this background noise here. And we're going to be using Noise Exterminator. It's a wonderful tool here, also from RC Astro. So we're going to be using RC Astro's Noise Exterminator, and we're just going to be applying it over our image. There we go, that cleaned it up quite nicely. And we're going to be using a little bit of some sharpening. I want to sharpen the bottom portion here where all that dark nebulosity is. There's going to be two ways of doing that. We're going to be using Utilities under Scripts and Dark Structure Enhance. Just only a little bit. I'm going to tone that down to about 20. There we go. Make those little dark regions pop out a little bit. And a really nice tool I like to use is also free. It's under Utilities and Event Sharpening. You just hit the sharpen button and it does all the work for you. It creates all the mask needed to sharpening or right on those edges. And it makes your image look quite nice. And there we go. Looking quite nice overall. Now I think we are pretty much done for the starless portion. So we're going to be renaming this starless. Now we're going to work on our stars. Now our stars are going to be kind of ugly because when they are done with the narrowband, what I like to do is create a star mask over top. So now we have our star mask. I'm going to apply that and hide it. And we're going to go back to that one utility. Correct for magenta stars, because we do have magenta stars in there. So we're going to go ahead and run that. Gets all that out. And then we're going to use SCNR for the invert. Get rid of any leftover green or magenta in those stars. And there we go. Our stars should be ready to apply back to our image. We're going to rename the stars. And then we're going to open up Pixel Math yet again. And we're just going to use the simple equation of starless plus stars. Create a new image. And there we have it. There is our combined image from two separate filters, the Askar filters, C1 and C2. We split the channels up and combined the hydrogen alpha, the oxygen 3, and the sulfur 2. We worked with our stars, and now you have a Hubble palette with a one-shot color camera, thanks to the amazing technology of Askar of providing a very affordable solution to start working with one-shot color cameras, so they get the same benefit as the mono users when coming to looking at these wonderful nebula pictures and be able to perform the Hubble palette. So that is a very easy way to do it very quickly. It only takes a couple of minutes and you got a wonderful result like this. Now, if you like what you have seen and want more tutorials like this, leave the comments down below, leave a like on the video. It does help me and motivate me to keep on doing this, and I hope this was very helpful for everybody, and I will see you in the next video, and clear skies.